Hi, class. Good morning. So today's lesson is going to be about potential difference, also known as or commonly as voltage. So, what is potential difference? There's actually a difference between what voltage is or potential difference is, the definition of what it is, and compared to what it actually does. Volts are what basically push that electric charge, those electrons basically around an electric circuit. So voltage behaves like a pushing force. Okay, so this is a kind of an analogy here where you've got the yellow guy here, which represents the voltage. He's pushing the charge, which is the green guy, which has got the symbol, the short form for amperes, amps, is pushing the amps, and then you've got this guy over here representing the resistance, the ohm, the guy that's representing the ohms. Okay, and this basically will slow down the electric charge. Okay, so voltage pushes the current and pushes that charge through conducting wires within a circuit. And the ohms is the resistance, which basically slows that down. And there's a very important relationship between the three of these, and we'll talk about those later. So in a battery, this push, as I've mentioned to you before, comes from chemical reactions that create a separation of charges. And the reactions basically cause an excess of electrons to accumulate at one end of a battery, so one terminal of the battery, therefore making it negatively charged on one end and leaving the other terminal, the opposite terminal, positively charged. So when these electrons accumulate, the reactions that cause them to accumulate on one end or terminal of the battery, they basically gain what is known as potential energy. They have the ability to do some work. So in a circuit, they will move around those conducting wires and go through different types of loads, and they will convert or drop off that energy and make it into a more useful energy. I don't know if I've mentioned to you before, but there's basically the law of conservation of energy, which states that energy cannot be created nor can it be destroyed. So therefore it goes through transformations, and that's exactly what happens in an electric circuit. The potential energy that is given by the battery, the push, is converted into different types of useful energy. Like, for example, in the circuits we've been doing, light bulbs give light. There's wasted energy that's wasted in an electric circuit in terms of with the load as being a light bulb. There's heat energy. So some of that energy is converted into light energy in the bulb, but not all of that potential energy is completely transferred to the light bulb to give light energy. It's actually given off. There's some energy that's given off as heat, which is basically wasteful, unless you're actually using an electrical heater in a circuit, and that's a different story. So the electrical energy stored in the battery is called electrical potential energy. So it's the energy that has the ability to do work and to do something useful. Electrical potential is also commonly referred to as what we know as voltage. So this is another little diagram here, and I know the wording is a little fuzzy, and I'm sorry, but I thought it was a good illustration to include in the slides. So this is a battery these are, this is the conducting wire over here, and this is what is known as potential difference. I'm going to talk about potential difference in a second, but that's exactly what creates this potential electrical potential energy. It's the potential difference. So there's chemical reactions that take place within the battery, pushing those electrons to one end and leaving these positive protons, positive charges at the other end. And as they come over here, they're energized, they're full of electrical potential energy, the energy to be able to do work. And when that circuit is closed, they are allowed to flow through these conducting wires. And as they flow through these conducting wires, though, they lose potential energy. Okay, so the potential energy that they have up here compared to down here is low. And this is what this is what we're looking at in terms of electrical potential difference. So more energy here they have up here, and they have less energy. And when we use a voltmeter, we are measuring from here to here. And that's basically what pushes those electrons through. Another useful analogy, I really like this one, is comparing basically a pump and a water wheel to a battery and a light bulb. So water flows due to a difference in gravitational potential energy. Okay, so the water is basically pumped. It goes up, is pumped, and as it's pumped, it's brought up to this higher location, I guess. And as it's brought up, it has a lot of gravitational potential energy to do work. So it basically is, when it's allowed to flow, it's going to flow, and the work will be the energy is transferred to this water wheel, and which works to transport water. So charges in a wire analogous to water in a pipe. The electric current is analogous to the flow of water. So again, something in the battery pushes these electrons to this level, and this creates the electrical potential energy. A gain in electrical potential energy. They've got lots of energy to do work, and now this is really this is conventional, by the way, conventional current. But as the electrons will go through this light bulb, they will lose energy because there is resistance in these conducting wires, and especially in this light bulb, there's resistance, and there's going to be a big difference between here and here in terms of electrical potential energy. So this is going to be voltage is measuring the difference between up here and down here. So the voltage is analogous to the change in gravitational potential energy. So let's just quickly summarize this. So in the analogy that you saw, the pump lifts a large amount of water. The water has some stored or potential energy. And if the water is allowed to pour out onto a water wheel, the energy of the falling water can be used to turn the wheel. And similarly, in this dry D cell, the cell itself, the chemical reactions give a huge number of electrons a certain amount of electrical potential energy. And just as the water molecules have gravitational potential energy at the top of the pump, so right up here, the electrons have electrical potential energy at the negative terminal of the dry cell. Okay. So electrons flow through a conductor when there is a surplus of electrons at one pole and a deficit at the other pole. And the electrical potential of the two poles is different. So there has to be, in order for the electrons to flow, there has to be a difference in electrical potential between the two sides of a cell or battery. Okay, so although the electrons have the potential for doing work when they are at that negative terminal, rearing to go, they can't do any work until the battery is actually connected to a load, any type of load, and those conducting wires, and when the circuit it has to be closed. So that's what potential energy does. What potential difference actually is. Okay, so potential difference is the difference in potential energy per coulomb of charge at one point in the circuit compared to the potential energy per coulomb of charge at another point in the circuit. Okay, so the units for potential energy per coulomb of charge are called joules per coulomb, or J over capital J over capital C. And this is the unit that has a special name, which is the volt. Okay, that's a simplified, the volt is a simplified unit which represents joules, which is the energy per coulomb, which is the charge. Okay, charge per coulomb. Okay, which is a volt. So if 1 coulomb of charge has 1 more joule of potential energy at one point in a circuit compared to another point in that circuit, the potential difference between those 2 points is just 1 volt. Okay, there's a mathematical relationship between the voltage and energy and charge, and this is what this mathematical equation is. Okay, so its potential energy is equal to the energy over charge. Okay, and it was this the term volt came from the person that worked on the whole area of potential difference, Alessandro Volta, which I believe from 1745 to 1827. And basically the term volt is in honor of his work on the on potential difference. Okay, so when we are measuring potential difference or voltage, we use what is known as a voltmeter. Just like an ammeter is used to measure current, which is the flow of electrons, so that we can figure out this whole area of charge. A voltmeter is used to measure the drop in electrical energy or pressure between 2 points in a circuit caused by electrical resistance when electrons flow through a conductor. So that is why the voltmeter is never placed within series. It is always connected in parallel. So in this circuit right here, you see the light bulb. You see it is placed across the light bulb, and the first question on one of the circuit diagram worksheet that you were given before this, it had a very simplified circuit like this. A lot of you thought it was parallel circuit because the voltmeter was placed in parallel, but this is just a simple circuit. The voltmeter, however, is placed parallel to the load because it measures the difference in potential energy over here to over here. There is a difference. We know that there's a difference because as the current moves through this load, it's going to it's going to be hindered because the load, the light bulb, is going to reduce the flow. It acts as a resistor, and some of that electrical potential energy is used to light that light bulb. And that's why it's going to be higher electrical potential energy here than compared to here. And that's what the voltmeter is reading. It's going to measure the difference between these 2 points in terms of electrical potential energy. Okay, and that's why we have to always place a voltmeter across the bulb. So as the electrons move here from the negative terminal of the cell, they will go around. They will basically lose energy as they go through the bulb here, and this will basically cause a reduction in the current or the electron flow. So let's do there's going to be lots of problems in terms of these circuits that we're going to start doing soon. But the first one, I figured that we'd start with a potential difference. So in a battery, 45 joules of chemical energy is converted to electrical energy by separating positive and negative charges. This energy places 15 coulombs of negative charge at the negative terminal, leaving a deficit at the positive terminal. What is the potential difference between the negative and positive terminals of the battery? So the first thing that we do, especially in math, we always write down what we are given. And I'm using a special pen here, and my writing, I have to write while it's not a flat surface. I'm writing on my screen, so the writing is going to be very messy, and I apologize. So what we are given is we're given what the energy is, okay, which is right over here. We're told that there is 45 joules of chemical energy. So I would write, okay, we're given energy, and we're also given, the charge, which is equal to, I've just crossed that out, 15 coulombs. Okay, so what is required for this problem is I want to know what the potential difference is. Okay, so I'm going to write PD in short, which is also equal to voltage. Okay, and we have to do this in volts, which is V, right? Voltage. I've just spelt that wrong. Sorry. It's really hard writing on there. Anyways, okay. And so in order to complete this problem, we need to analyze it, and we need to use an equation for that, which I already gave it to you in the other slide. Okay, so voltage is equal to E over Q. So energy over charge. Okay, so and then the solution, we plug in our values here. V is equal to 45 joules over 15 coulombs, which is equal to 3.0 joules per coulombs. And we can write this as 3.0 volts, okay? And therefore, our statement, I'm going to write that here too, because this is a proper GRASS method of doing the problem solving. So a battery uses, a battery that uses 45 joules of chemical energy to separate 15 coulombs of charge has the potential difference of 3.0 volts between the negative, I'm running out of space, so I'm using short form now, negative and positive terminals of a battery. Okay, and so that's how you do this type of problem. I hope that this was okay in terms of you understanding what I was trying to teach you. I will see you next time with a different lesson, and we are going to be talking about resistance and ohms in our next lesson. There is going to be some homework associated with this lesson, so please make sure that you take a look at that too. Have a wonderful day. I'll talk to you again